So shall we continue?
Yes, sir.
Yes, sir.
Okay, okay. Now listen, all of you, pay attention. Last time we have done with the different number systems. I have told you the representation. I have told you what is a weighted number, or what is a weighted position, their positional value, how it is represented. Okay, then the integer part, fractional part. Okay, so this integer fractional part, this is applicable for all the number systems. That is a decimal, let it be binary, let it be octal, let it be hexadecimal, whatsoever. Okay, so okay, is my screen visible? Can you see the
Yes.
Iron Man?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay.
Nice wallpaper, sir.
Thank you. This is all my son has created.
Nice one.
Yeah. Okay. So I was talking about the integer part and fractional part. So this is applicable for decimal. This is applicable for octal, binary, and hexadecimal. Last time I think I have explained you in detail about the decimal number system and how it is represented and what is the weight, what is the positional value. Okay. For example, if I'm taking a number, it is number is suppose 788. Okay, and if you see the number, it is a decimal number, so the base should be 10. The base is 10. And how do you represent this number, or what is the positional value? I have told you the positional value of 8 is 8 into 10 to the power of 0, plus what is the positional value of this second? This is 8 into 10 to the power of 1. And what is the positional value of this 7? That is plus 7 into 10 to the power of 2. So when you add all these number, you will get this 788. So that is the meaning. That is 700 plus 80 plus 8. So it gives you 788. Now this is also applicable for binary number if you take. Now first we have talk about the decimal number now. Now whenever you talk about the decimal number, its representation is important. You have to understand what is the significance of each and every digit. Okay, we say it is a digit. Okay, what is the other name other than digit? हमने क्या बोला था? It is called as a symbol. Okay, each digit or a symbol. Now when you talk about the binary number system, now in the binary number system, if you take an example, whether I have started with the binary number system, I think
Yes, sir.
I have done with the binary, na? I have started with the binary.
Yes, sir.
Okay.
Yes, sir.
Now when you talk about the binary, if you talk a number that is 1001, the first thing, it is a binary. It is a binary. Now this binary number is in the form of ones and zeros. Okay. Now we will see something about this 1001. Now here we call as a digit or symbol, but in binary number system it is called as a bit. It is called as a bit. Okay. So bit 1 is a bit, 0 is a bit, 0 is a bit, and again 1 is a bit. So if I say there are 4 bits, there are 4 bits. Okay. Now there is a significance of this bit, and there is significance of this bit. The bit which you see at the unit place. Okay. Now here we will not say unit, tenth, and hundred, because that is applicable for decimal number. Okay, that is applicable for decimal number. That is applicable for decimal number. Now here, this bit is called as LSB. That is least significant bit. That is least significant bit. And this bit is called as MSB, which is called as most significant bit. Most significant bit. And this is called as a least significant bit. Now MSB and LSB is also applicable for decimal number. This is also applicable for octal number. This is also applicable for hexadecimal number. Okay. So whenever you see the rightmost digit, it is called as LSB, and the last bit towards the left hand side, it is called as MSB. Now why it is called as a LSB? Because it is having a least significant, because it has a least weight. How we can see that it is having a least weight? Now I am talking about the binary number system. So what is the weight of this particular bit, which is called as LSB? The weight of this is 2 to the power of 0.
0.
Yes, 2 to the power of 0. Now मैंने जब लिखा था आपको 1001, and as you know that this is a binary number, so base of this binary number comes to be 2. So what is the weight of LSB? It is 2 to the power of 0. What is the weight of this one? It is 2 to the power of 3. 2 to the power of 3. Okay. Now when you say 2 to the power of 3, it comes to be how much? 8. When you say 2 to the power of 0, the weight comes to be 1. Now position of this one at LSB, the weight is 1, and the weight at the MSB, the weight is 8. The weight is 8. That is why always the most significant bit will have the highest weight as compared with the LSB, or you can say LSB always has the least weight. It always has the least weight. सबसे कम से कम weight LSB में होता है. Okay. Now I have given an example of 1001. Okay, 1001. So how do you represent this binary number in terms of to the power of 2? How do you represent this? It will be represented in the same manner, only it is multiplied by to the power of. So it is 1 into 2 to the power of 0. This 0 will be represented at 2 into 2 to the power of 1. You have plus sign, don't forget. This 0 is having the representation in the form of 0 into 2 to the power of 2, and this one is represented as 1 into 2 to the power of 3. So this gives you 1 into 2 to the power of 3, it gives you 8. This gives you 0, this gives you 0, and this gives you 2. So when you add this, it becomes 10. Okay. Now ये जब करने के बाद जो आंसर आ रहा है मुझे 10. Now see here, I have taken this number as 1001. Again, I want everyone to pay attention. I am explaining you all the basics, all the fundamentals. आप लोगों को जिन लोगों को पता है, it's well and good. जिन लोगों को नहीं पता है, please pay attention. I have taken the number as 1001.
Sir, it will be 9, na?
8.
Yes, sir.
Yes. Sorry. It is 1. Okay, so it comes to be 9. ठीक है, मैं एक दूसरा नंबर लूंगा जिसका आंसर 10 आता है. ठीक है, तब मैं आपको और समझाऊंगा. So when it comes to be 1001, please make the correction. It is not 2, it is 1. So it comes to be 9. Now when I'm taking 1001, I have already mentioned that it is 2. The base is 2, so you have understood this is a binary number. When you are representing it in the form of 2 to the power of, the representation will give you, or it will fetch you the number that is 9. Now when I'm talking about 9, now the question arises whether this 9 represents which octal number, hexadecimal number, or it represents a decimal number. The first thing, it will not represent octal number, because you know the symbols present in the octal number, it is from 0 to 7. So 9 doesn't fall in 0 to 7 number, so it is not part of the octal. It is not the part of octal. What about the hexa? Now when you talk about the hexa, yes, the range of hexadecimal number is from 0 to 9 and A to F. So yes, it can be hexa. What about the decimal? The decimal symbols range from 0 to 9. So you have a 9, so it can be also a decimal number. Now we have to rule out whether this, क्योंकि 9 number दोनों में नहीं आ सकता है, it cannot be as decimal. When you do this type of a representation, it can be either decimal, or it can be hexadecimal. So whenever you are representing a number in terms of 2 to the power, please pay attention. Whenever you represent any binary number into the 2 to the power, whatever the final answer you get, it will be by default decimal number. Hexadecimal is ruled out. So whatever the 9 number you have got, that is purely decimal number. Okay. Now let me take another example. I am purposely taking the number. It is 1010. Okay. It is a number, so to the base is 2. This representation. Now I am directly writing down the I want everyone to have a keen observation here. So 0 into something will be 0, plus 2 to the power of 1, it will be 2, plus 0 something is 0, by something is 0, and this one representation is 2 to the power of 3, it will give you 8. So it comes to be 10. अभी और एक बात यहाँ पे है, जहाँ पे बेस डिफाइंड है, यहाँ पे 2 लिखा है, तो आई विल कॉल दिस नंबर 010. I will not call this number as 1010, but whenever it is written base as 10, then it is called as 1000 and 1010. How pronounce the number, that is all depends upon the base value. What is the base value? ठीक है, तो जो बेस हमने 2 लिया है, इसलिए मैं इसको 1010 बोलूंगा, because it is in the form of bits number. The binary number are said to be in the form of bits, so it is 1010. We will not say 1010. But when you convert this number, now this is what, this is a representation in the form of 2 to the power of, okay, and you answer as 10. Now here I will not say 10, here I will say 10, and you know, when in the form of 2 to the power, whatever the default answer you get, that is always decimal number. लिखना पड़ेगा 10, उसके नीचे लिखना पड़ेगा 10. Okay, ये नंबर मैंने इसलिए लिया. How this and how do you pronounce this? This is pronounced as 1010, pronounced as 10, not 10, only because यहाँ पे base है 2 और यहाँ पे base. I hope you have understood this. If you have any question, please ask, so that we can proceed further. Any question, any doubt you have? Someone has to acknowledge, please.
No, sir.
No, sir.
Okay. Okay. Now this is how the representation of 1 is there, in the form of 2 to the power of. Okay, in the form of 2 to the power of. Okay, and I have told you what is LSB, what is MSB. Now as far as MSB and LSB is concerned, this is applicable for all octal, decimal, hexadecimal and binary. Okay, सिर्फ ये याद रखना, सबसे right most is called as LSB, सबसे left most is called as MSB. It is called as MSB. Okay, so this is all about the binary number. Now in the octal also I have told you, okay, you take any number. If I'm taking 235 and the base of octal is 8. Now here is also the question is, how do you represent this 235 in terms of 8 or to the power of 8? The same thing repeats. 5 into 2 to the power to 5 into 8 to the power of 0, plus 3 into 8 to the power of 1, plus 2 into 8 to the power of 2. Okay, and whatever the representation you will get, that representation is in the form of, okay, that is in the form of decimal number. लेकिन हम अभी ये नहीं करेंगे. When I will be talking about the conversion of number system, that time I will explain it. Whenever I will be talking about the conversion of this number system, that is from decimal to binary, binary to decimal, decimal to octal, octal to decimal, and so forth. So different types of conversion जब हम देखेंगे, that time I will explain you that how do you convert the number. Okay, and same thing is applicable for hexadecimal number also. If I'm taking a number as suppose A, 3 and 5, hexadecimal number system में आपको मैंने बताया था कि it ranges from 0 to 9 and A to F. So 835, this is how we say the number of hexadecimal. Okay, and the base will be 16. Again, how do we represent this in the power of 16? Again, 5 into 16 to the power of 0, plus 3 into 16 to the power of 1, and A into 16 to the power of 2. Now you will say, sir, how A into 16 power of 2? Then in that case, A has to be written in the decimal form. So what is the equivalent of A in decimal form?
10.
What is the equivalent of
10.
11.
10? Yes, मैंने आपको बताया था ना. I think I have told you that it is 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, then 9, then comes A. Now these are all in hexadecimal. When you want to convert into decimal, वो conversion मैं आपको बाद में बताऊंगा. but this will represented as 1 in decimal. This will be represented as 2. This will be represented as 3, 4, 5, 6, 7, 8, 9, and after 9, A is represented as 10. It is represented as 10. Okay. तो जब हम A को मल्टीप्लाई करेंगे, that is A into 16 to the power of 2, that means 10 into 16 to the power of 2. That is how it is calculated. That is the representation of hexadecimal number. Okay. So I have talked about the representation. रिप्रेजेंटेशन का ये फॉर्म, यही मतलब होता है कि हम उसके बेस से मल्टीप्लाई करते विद देयर इंडिविजुअल वेट्स. हर एक के पोजीशन को हम उसके वेट से मल्टीप्लाई करते टू द पावर ऑफ. ओके. तो जैसे जैसे बेस रहेगा वो हिसाब से हम उसके मल्टीप्लीकेशन को हम उसको मल्टीप्लाई करते. ओके. दैट इज हाउ यू रिप्रेजेंट द एनी बाइनरी, एनी डेसिमल, एनी ऑक्टेल एंड एनी हेक्सा. सो अगर क्वेश्चन पूछा जाता है जस्ट गिव द रिप्रेजेंटेशन, तो आपको सिर्फ मल्टीप्लाई करना है विद देयर इंडिविजुअल पोजिशनल वेट्स, with their individual positional weights. Okay. Now this is what we have understood till now. We will go to the PPT. So I have told you about what is the place value, what is the place value of individual position. Okay. So this thing I have already told you. We will see now the conversions of number. We will see now the conversions of number. So if you have, please write down in your register. I already asked you to have registered with you during my class. Whenever required, I will ask you to write down something. Okay. Now you can write down. You can write down number system conversion. Write down the number system conversion. We will go one by one, step by step. Write down the heading as number system conversion. Number system conversion. और एक मैंने शायद वो एक बात बताना, I just forgot to tell you, that is if you take a binary number, if you take the binary number as 1001 dot. Now can you see the dot? Dot का explanation मैंने पहले दिया था. And if I write down 101, now this dot is called as a radix. But you know this is a binary number. You know this is a binary number. So this is called as binary point. This is called as binary point. Binary point. Similarly, if I'm writing down 322.12, if this is an octal number, the base is 8. Here, this point that is called as a radix, and in particular, it will be called as octal point. It is called as octal point. So you have octal point, you have binary point, you have decimal point, and you have hexadecimal point. So that is all reflects the radix point. तो जो नंबर सिस्टम में हम बात करेंगे उस नंबर सिस्टम का अगर हम पॉइंट रेडिक्स की बात कर रहे हैं तो उनके नंबर सिस्टम के हिसाब से उसका पॉइंट नाम दिया जाता है. सो डेसिमल पॉइंट, हेक्साडेसिमल पॉइंट, ऑक्टल पॉइंट और बाइनरी पॉइंट. ओके. बाइनरी पॉइंट. नाउ आप अगर बोलोगे कि हाउ डू यू रिप्रेजेंट दिस इन द फॉर्म ऑफ 2 टू द पावर ऑफ, यहाँ पे हम इसको मल्टीप्लाई कर देते 2 टू द पावर ऑफ 0 से, वैसे ही यहाँ पे हम ये 0 को मल्टीप्लाई करेंगे 2 टू द पावर ऑफ -1. ये 1 को हम मल्टीप्लाई करेंगे 1 इंटू 2 टू द पावर ऑफ -2. ये 0 को हम मल्टीप्लाई करेंगे 0 इंटू 2 टू द पावर ऑफ -3 एंड सो फोर्थ, डिपेंडिंग अपॉन फ्रैक्शनल पोजिशंस कितने हैं, और यहाँ पे डिपेंडिंग अपॉन हाउ मेनी इंटीजर पोजिशन वैल्यूज भी है. ओके. सो व्हाट आई मीन टू से दैट all the integer parts will be multiplied by 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and so forth. And fractional part will be multiplied by 2 to the power of -1, 2 to the power of -2, and so forth. The same thing is applicable here also. here if I were to represent the power of 8 to the power of, then this will be 1 into 8 to the power of minus 1. This will be 2 into 8 to the power of minus 2, and so forth. Same thing is applicable for decimal number as well as it is applicable for hexadecimal number. Okay, so here that point was left about the fractional part. How do you represent? Okay, then the base to the power of minus 1, minus 2, minus 3, and whatever the radix point we are considering, depending upon which binary number which number system I am talking about, depending upon that the radix will have its particular name. It can be octal point, binary point, decimal point, or hexadecimal point. Okay, so what you have written? You have written now number system conversion. Number system conversion. We will go one by one. The first one is, write down in the number system conversion. The first one is binary to decimal conversion. Binary to decimal conversion. Binary to decimal conversion. So please see on your screen now. See on your screen. Whenever you talk about the binary number system, my screen is visible to everyone.
Yes, sir.
Yes, sir.
अभी देखो, हमेशा बच्चों को यहाँ पे गलतियां होती है क्योंकि हमको काफी कन्वर्जन देखने पहली बात तो हम 4 नंबर सिस्टम से हमने फर्स्ट ऑफ ऑल वी हैव स्टडीड 4 नंबर सिस्टम. नाउ वी हैव टू सी देयर इंटरकन्वर्जन. Okay, we have to see their interconversions. So most of the students they will have the confusion. So that's why I'm asking you to write it down with one example so that you will be able to understand in a proper way. And you have to study in the same sequence. तब जाके आपको अच्छे से क्लिक होगा दिमाग में. And whenever you practice more, then you will have more command. और वो टाइम पे क्या होता है, you do not require pen in your hand. आप directly in mind you will do the calculations and you will give me the conversion output. You will give me the converted output. Okay, now see, but as it is an initial stage, it's my duty to take in a in a systematic manner. But once you have a command on this, then you will be able to understand. Okay, तो आपने नंबर सिस्टम कन्वर्जन में सबसे पहले आपने लिखा है बाइनरी टू डेसिमल कन्वर्जन. ओके, बाइनरी टू डेसिमल कन्वर्जन. So let me tell you that we have binary number, then we have a decimal number, then we have an octal number, then we have a hexadecimal. Okay, we have a decimal. So binary, decimal, octal, and hexa. Now the first conversion is binary to decimal. Okay, this is the first conversion. Then the second conversion will be from binary to octal. Okay, then the third conversion will be binary to hexa. So whenever you do binary to decimal, we are going to see the first. Okay, with an example. Then at the same time, what I'm going to plan, what I'm planning, when after doing binary to decimal, in the same case we will see decimal to binary. So this becomes your second part. Okay, ये होने के बाद, now this is what pictorial view I'm giving. Okay, this is what is the pictorial view. Okay, तो आपको ये याद में रखना है जो मैंने यहाँ पे बनाया. You can write down this. Write down BDOH. Somewhere in the corner of the register of the page you can write down BDOH. Okay, तो सबसे पहले हम देखेंगे binary to decimal, and at the same instant we will say decimal into binary. Then we will see binary into octal. कैसे this will give you an idea कि actually कैसे conversion होता है और क्या sequence में हम follow कर रहे हैं. So it will be like binary into octal. At the same time we will say octal into binary, then binary into hexa, and at the same time hexa into binary. Okay, this is how we will see. Now as it is applicable for binary to, हमने देखा कि binary to other number system and the other number system into the binary. Then what the next thing is, we will see decimal into octal, and at the same time octal into decimal. But see, as per your syllabus, I will see if this is the part which is included in the syllabus, I will take. Otherwise, I will not include in the explanation. Okay. Then same thing, decimal into hexa and hexa into decimal, and the last remains octal into hexa and hexa into octal. Okay. So the first important thing is that you should have an holistic view of B, D, O, H and their conversion. Okay. So we are taking binary as the first, then comes second decimal, then comes octal, then comes hexa. Okay. So we will see the interconversion now. So taking a number, write an example. I am taking a number as 110011. 10011. Now there are 2 or 3 methods are there. How do you convert this into a decimal number? But I am asking you to stick only one method. Okay, that is the easiest method. So we will see what is that method. So whenever you have any binary number, now they have given binary number as 110011. So पहले हम वो करके देखते हैं यहाँ पे 11011. This is the binary number they have given, and they are asking us to convert into decimal number. Okay. So follow my method. Okay. If you are interested, you can see the other methods also, but stick to any one method. Now here we have to see the positional values. Okay. Now with the prior basic knowledge, I am directly writing down their respective position weights. I am writing down their respective positional weights. Okay. So what is the positional weight? The positional weight of LSB is 2 to the power of 0. Positional weight of this one is 2 to the power of 1. Then 2 to the power of 2. Then 2 to the power of 3. Then 2 to the power of 4. Okay. 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. This is for this, this is for this, this is for this, this is for this, then this is for this. Okay. Now you know anything which is multiplied by 0 will give you 0 answer. So this I am going to neglect. So 2 to the power of 0 will give you 1. 2 to the power of 1 will give you 2. 2 to the power of 3 will give you 8. And 2 to the power of 4 will give you 16. Okay. So 1, 2, 8, 16. And when you do the addition of this, tell me the answer. When you do the addition of this, tell me the answer. Yes, any one of you?
27.
Yes, 27. What is the base? What is the
10.
base?
10.
10. Because we are converting 11011 into decimal जिसका base रहेगा 10. So question mark is there. So question mark is replaced by 27. So 27 is the answer. 27 is the answer. Now I want everyone to pay attention. I am going to write down the weight of each position from LSB to MSB. So you have to remember this. Dot, 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 and dot. LSB position of a binary number is 1. उसके बाद नेक्स्ट जो आएगा वो आएगा 2. उसके बाद जो नेक्स्ट आएगा वो आएगा 4. उसके बाद जो आएगा वो आएगा 8. उसके बाद जो आएगा वो आएगा 16. उसके बाद जो आएगा वो 32. Tell me the next number.
64.
64.
Yes, 64. अभी यहाँ पे जगह नहीं है. 64 के बाद क्या आएगा?
128.
128.
128.
उसके बाद क्या आएगा?
254. 256.
256.
6.
Yes, and so forth. So depending upon how many number of ones you have, you have to consider those values. So here in my case 1, this one and this one. That's why I have taken 1, 2. I have omitted 4 because उसके जगह पे 0 है. उसको omit मैंने क्यों किया? Because anything multiplied by 0 will give you 0. इसलिए उसको मैंने omit किया है. I have taken 8 and I have taken 16. So whenever you add these 1, 2, 8 and 16, you will get 27. You will get 27. Now directly you can tell me the answer for 11100. I am writing down the weight. 1, 2, 4, 8, 16. Tell me the answer fast.
26.
एक मिनट. हाँ. 1, 2, 4, 8, 16. Answer comes to be
28.
20.
28.
28 to the base of 10. 1111111. Tell me the answer. One, 2, 4, 8, 16, 32.
63.
63. I'm relying on your answer. Please cross check others. 63 is the right answer?
Yes, sir.
Yes, sir. Yes.
Yes. So whenever you are converting binary into decimal, you have to remember the weights. खत्म. You have to remember the weights. खत्म. जहाँ पे 0 है वो नहीं लेना है. For example, 11000. This is base 2. This is base 2. 1, 2, 4, 8, 16. ये 3 नहीं लेना है क्योंकि ये 0, 0 पे. डायरेक्ट 16 plus 8.
24.
24.
24.
Very good. 24 is the answer. 24 is the answer. Okay. So I expect that you will remember this method with the weights. With the weights. Okay. So the weights are 1, 2, 4, 8, 16, 32, 64, 128, and so forth. So and so forth. Okay. So this is the binary to decimal. This is the binary to decimal. Okay. This is the binary to decimal. अभी कभी कभी ऐसा भी क्वेश्चन पूछे जाते हैं. फॉर एग्जाम्पल अगर मैंने लिखा है, आई एम टेकिंग अ सिंपल एग्जाम्पल, डॉट 1 1, ये है 2. आई वांट इक्विवेलेंट इन द फॉर्म ऑफ डेसिमल. सो दैट मीन्स बाइनरी नंबर कन्वर्टेड इट इनटू डेसिमल. नाउ सपोज दिस इज एन एग्जाम्पल. अब जब तक बाइनरी पॉइंट नहीं था तब तक ठीक था, लेकिन जब बाइनरी पॉइंट आता है देन वी हैव टू डू सम कैलकुलेशन. ओके. एज फार एज इंटीजर पार्ट इज कंसर्न, जो हमने अभी सीखा है वही हम वहाँ पे अप्लाई करेंगे. बट एज फार एज फ्रैक्शनल पार्ट इज कंसर्न, वी हैव टू डू सम कैलकुलेशन. व्हाट इज दैट कैलकुलेशन? द सिंपल कैलकुलेशन. पहले हम इंटीजर पार्ट के लिए बारे में देखते हैं. इंटीजर पार्ट में इसका वेट है 1, इसका वेट है 2. ओके. सो 2 + 1 गिव्स यू 3. ओके. ये हो गया integer part के लिए. What about the fractional part? Fractional part is also simple. It is also simple. What is that? It is 1 into 2 to the power of -1 plus 1 into 2 to the power of -2. Any one of you please do this calculation. Tell me the answer.
3.75.
3.75 ना?
हाँ.
हाँ. सो ये जो कैलकुलेशन करेंगे उसका आंसर है 0.75. इसका जो कैलकुलेशन करेंगे उसका आंसर है 0.75. और इसका जो कैलकुलेशन करेंगे जो नॉर्मल मेथड से मैंने वेट का बताया था वो है 3. सो आंसर कम्स टू बी 3.75. द आंसर कम्स टू बी 3.7. ओके. 3.75. ओके. एनी वन ऑफ यू टेल मी व्हाट इज 2 to the power of -1? उसका आंसर क्या है?
0.5.
0.5. 2 to the power of -2 का बताओ.
0.25.
0.25.
2 to the power of -3 का बताओ.
0.125.
0.125.
हाँ. तो ये जो चीजें है ना, ये हम याद में नहीं रह सकते, लेकिन आप 4 डेसिमल तक 4 पोजीशंस पे याद रख सकते तो याद रखो, ताकि आपको अदरवाइज नॉट रिक्वायर्ड. दिस इज जस्ट आई एम गिविंग यू एन अंडरस्टैंडिंग, बिकॉज अदरवाइज यू विल बी यूजिंग कैलसी, देयर इज नो प्रॉब्लम. बट जैसे हमने यहाँ पे जो याद रखा था 1, 2, 4, 8, 16, ये तो याद रह जाता है. देयर इज नो हार्म. ये तो याद रह जाता है. देयर इज नो हार्म. ओके. ये चीजें याद रहती है ये, लेकिन ये चीजें चार पोजीशंस तक आप याद रखो, अदरवाइज इट इज फाइन, आपको प्रॉपर मल्टीप्लाई करना पड़ेगा यहाँ पे। लेकिन और एक बात है, अगर मैंने लिखा 101, मैंने अगर लिखा 101, तो ये जो रहेगा ये हमको ओमिट करना पड़ेगा। ओके, तो वो केस में क्या रहेगा, 101 यानी बाइनरी पॉइंट के बाद जो फ्रैक्शनल पार्ट है 101, तो इट विल बी 0.5 एंड 0.125। तो ये दोनों ऐड करके मुझे बताओ 0.5 और 0.125 ऐड करके क्या आंसर आता है?
0.65.
हाँ, तो ये केस में 11.101 ये जो बाइनरी है, ये जब डेसिमल में कन्वर्ट करेंगे वो आएगा 3. यस, क्या आंसर है वो?
0.625.
यस, 0.65 और बेस रहेगा 10।
625.
अच्छा, 625. ओके, 625. सो व्हाट आई मीन टू से दैट जहाँ पे 0 है उसको, वो पोजीशन को हमको इग्नोर करना है, और जहाँ पे 1 है वही पोजीशन के वेट को हमको कंसीडर करना है। ओके, तो आपको रखना है याद 1 2 4 8 16, और हो सके तो 4 पोजीशंस के लिए याद रखो 0.5 0.25 0.125 एंड सो फोर्थ। ओके, दिस इज अप टू यू, बट यू हैव टू रिमेंबर दिस, देयर इज नो अदर वे, यू हैव टू रिमेंबर दिस। और जहाँ पे 1 है वो पोजीशन को कंसीडर करो, जहाँ पे 0 है वो पोजीशन को निग्लेक्ट करो। शैल वी प्रोसीड फर्दर नाउ?
Yes, sir.
Any questions, any doubt? Am I going very fast, or the speed is fine?
Fine, sir.
Okay. So this was all about your binary to decimal conversion. Now come to this particular example. Come to this particular example. Yes. So the number I have taken 1101. वही आपने उन्होंने वही किया है, 110011 लिया है। ये वन पोजीशन 00 को हमने निगलेक्ट किया है। Now see what is going to happen. 32 16 0 0 1 2, that is 51. तो मैंने जो वही बताया था, वी हैव टू रिमेम्बर द वेट्स 1 2 4 8 16 32। 8 और 4 को निगलेक्ट क्यों किया है? क्योंकि वो जगह पे 00 थे, खत्म, and that's why we have got 51. So when you add 32 plus 16 plus 2 plus 1, you get 51. Okay, so it is not a rocket science, but हाँ, लोगों को लगता है कि हमको आता है, सब आता है, but this is the fundamental and each and everyone should know this. Okay, so here we have seen the conversion. Now convert the following binary number into decimal number. They have given example of 1001. Again the answer comes to be 9. Directly करना भी, हमको क्या ऐड करना है? 1 plus 8 gives you 9. अब हमको ये सेकंड में क्या ऐड करना है? 1 2 4 8 which gives you 15. थर्ड में हमको क्या ऐड करना है? सिर्फ 2 को ऐड करना है, बाकी की सब पोजीशन 0 है, तो आंसर इज 2. ओके, आंसर इज 2. सो दिस इज ऑल binary to decimal. Write on the next one now. Decimal to binary. Decimal to binary. Decimal to binary. Decimal to binary. अब decimal to जब binary हम करेंगे, ये भी important है. Now here there is no shortcut. Okay, you have to actually do. I will explain you with an example so that you will be able to understand in proper way. I will take a simple example. I will take with the decimal point कि ताकि उसी केस में सब समझ में. I am taking a simple example. I want to convert this decimal number 23 point suppose 23.41. This is in decimal. I have to convert into binary. Now as there is a decimal point, I'm very particular. It is a decimal point. Here also there will be a point which is a binary point. So here it is a decimal point. Then after conversion you will have a binary point. Now we have to do some calculations on integer part 23 and some calculations on fractional part, that is 41. So these will be done separately. 23 का जो भी कैलकुलेशन आएगा वो यहाँ के इंटीजर पार्ट में चला जाएगा, फ्रैक्शनल पार्ट का जो भी हम कैलकुलेशंस करेंगे वो ये पार्ट में चला जाएगा। अब 23 में हमको क्या करना है, 23 को हमको क्या करना है, 23 को हमको कुछ नहीं करना है, 23 को हमको सक्सेसिवली डिवाइड बाय 2 करना है, डिवाइड बाय 2 करना है। यहाँ पे डिवाइड बाय 2 क्यों करना है, बिकॉज आई एम कन्वर्टिंग डेसिमल इनटू बाइनरी। ये भी बच्चों को कंफ्यूजन होता है कि सर हम 2 से क्यों कर रहे हैं, हम 8 से क्यों नहीं कर रहे, हम 16 से क्यों नहीं कर रहे। हम बाइनरी में कन्वर्ट करना चाहते हैं तो हमको वो नंबर लेना पड़ेगा, बेस 2 है तो आई हैव टू टेक सक्सेसिव डिवीजन बाय 2, सो दिस इज कॉल्ड एज सक्सेसिव डिवीजन बाय 2। और इंटीजर फ्रैक्शनल पार्ट को क्या करना पड़ेगा, सक्सेसिव मल्टीप्लिकेशन बाय 2। ओके, तो वी विल गो वन बाय वन। सो 23, टेल मी 2, टेल मी फास्ट। So 23 divided by 2, tell me the quotient.
11.
11.
Yes. What is a remainder?
1.
1. Divided by 2, it comes to be 5.
5.
Remainder 1. 2 2s are 4, remainder 1, and 2 1s are 2, remainder 0, remainder 0. Okay, remainder 0. Now here we have to see that whenever you are doing this type of calculations, okay, whatever the number we are getting here now, we have to focus on the remainder only. So these remainders we have to focus: 1 1 1 and 0. But don't forget, we have to actually see that we have to also consider from which sequence, so here we have to go from bottom to top. The arrow is important, the arrow is important, the arrow is important. Okay, now whenever you talk about this arrow, जब हम successive division करते हैं और हम we are interested in remainder only, then we have to take the numbers from bottom to top, from bottom to top. So the remainder numbers which will be considered not from 0 but will be considered from 1. यहाँ पे भी बच्चे गलतियां करते हैं. We have to take from this. We have to take from this. Okay, we have to take from this. So the numbers, how do you write down the number now? How do you write down the number? About the integer part, जो हमको यहाँ पे लिखना है, fill in the blanks में. Okay, that comes to be from bottom to top approach. So we'll write down this 1 first. So it is 1, then this 0 0, then this 1 1, then this 1 1, and then this 1, then 1. तो हमको इंटीजर पार्ट आ गया, 10111 is the integer part. 10111 is the integer part. Okay, और आपको अगर क्रॉस चेक करना है, you tell me if 10111 is a binary number, what is the equivalent of 1011 in decimal number? Again, this is 1 2 4 8 and 16. I will not consider 8 because वो जगह पे 0 है. Tell me 16 plus 4 plus 2 plus 1.
So 23.
Yes, you have got this 23. You have got this 23. So this is how you can cross check. Okay. See, ये मैं आपको दिखा रहा हूँ, लेकिन आपको एक बार कमांड आ गया ना 1 2 4 8 16 का, then directly you can write down the answer. Directly you can write down the answer. Okay, but for that you require more practice. For that you require more practice. So you have got 10111. यहाँ पे सबसे इम्पोर्टेंट दो चीज याद रखनी है. सबसे पहली चीज है, हमको रीड करना है बॉटम से टॉप, और दूसरी चीज हमको याद रखनी है कि इसको निगलेक्ट नहीं करना, क्योंकि बच्चे क्या करते हैं, आंसर डायरेक्टली 0 1 1 1 लिख देते हैं. Yes, you can cross check, that is absolutely fine, but why do you waste time? You should know this, that you have to take from this also. So we will write down here 1 also. So 10111. So this is about the integer part. What about the fractional part? That is by using the successive multiplication. So I will take the successive multiplication here. So I was talking about 23.41. हमने 23 के बारे में देख लिया। 41 के लिए क्या करना है? 41 के लिए हमको सक्सेसिव मल्टीप्लाई करना है। अभी 0.41 है तो इट इज 0.41 मल्टीप्लाई बाय 2। टेल मी द आंसर।
0.82.
0.82। इसमें हमको इंटरेस्टेड है। अब जैसे सक्सेसिव डिवीजन में हम इंटरेस्टेड थे रिमाइंडर में, सक्सेसिव मल्टीप्लिकेशन में आई एम इंटरेस्टेड इन इंटीजर ओनली। I am interested in the integer only. So you can write down here 0. So 0.82 multiply by 2. Tell me the answer. Do on your
1.64.
1.64. Yes, 1.64. I am interested in the integer. Write down 1. 1.64 into 2.
So 3.28.
3.28.
3.28. Now here the problem arises that whenever you are multiplying the number, okay, whenever you multiply by the number, you should not take the integer part. ये मैंने आपको इसलिए बता रहा हूँ कि यहाँ पे बच्चे गलतियां करते हैं। यहाँ पे जब मैं 1.6, I want everyone to pay attention. This is very important. मैंने लिखते समय 1.64 लिखा और मैंने इंटरेस्टेड इन द इंटीजर पार्ट मैंने 1 यहाँ पे लिख दिया। लेकिन मैं जब यहाँ पे लिखूंगा, अगर मैं 1 लिखा, दैट मीन्स यू हैव क्रिएटेड अ sin. आपने गलती नहीं की, आपने पाप किया। ओके, सो व्हेनेवर यू आर क्रिएटिंग सम sin, that means your answer goes into that is a blunder now. So here instead of taking 1 point, you should take 0 point. You should take 0 point. इसका मतलब यहाँ पे जो भी आएगा ये सब इंटीजर पार्ट्स आने वाले, इंटीजर पार्ट्स सॉरी फ्रैक्शनल पार्ट्स आने वाले। जैसे 0.41 यहाँ पे आ गया, 0.82 यहाँ पे आ गया, 0.64 यहाँ पे आ गया। तो टेल मी 0.64 into 2 how much?
1.28.
1.28. 1.28. Yeah, I'm interested in this integer part. 1 I will write down here. यहाँ पे लेते समय I am interested in fractional part. So 0.28. तो याद में रखो, here I am interested in fractional part only. ये दिमाग में अच्छे से डालो। बच्चे यहाँ पे गलतियां करते हैं and they are not getting answer. They are they are giving the wrong answer because all the binary numbers will be in the form of 0 and 1. लेकिन आंसर बच्चे ये भी लिखते हैं, 3 लिखते हैं। आप देखो यहाँ पे 3 था, अगर आप यहाँ पे 3 लिखते थे तो आंसर में भी 3 लिखते थे आप। And you know that binary number has only 2 symbols, 0 and 1. So 3 is not an answer. So 3 is wrong. Okay. So what I meant to say that always write down the fractional part. Okay. So fractional part में यहाँ पे 1 आया तो आपने यहाँ पे 1 लिखा, यहाँ पे 1 लिखा। 0.28 है। It depends upon आपको कितने आगे जाना है। हम सिर्फ 3 प्लेसेस पे चलते। अब वहां पे जब सक्सेसिव डिवीजन कर रहे थे, हम बॉटम से ऊपर जा रहे थे, यहाँ से हम ऊपर से नीचे आएंगे, ये भी याद में रखना है। तो यहाँ पे भी 2 चीजें याद रखनी है। राइट डाउन फ्रैक्शनल पार्ट ओनली, राइट डाउन फ्रैक्शनल पार्ट ओनली and take the numbers from top to bottom, and take the numbers from top to bottom. So if I take the number from top to bottom, it comes to be 0, 1, 1. So what is the total answer now? Total answer 10111, 10111 और इसका 011. So combine together, so it comes 011. So this is your final answer. This is your final answer. I am going to take only one example for every conversion ताकि उसी में आपको सब समझ में आए। Okay, ताकि उसी में आपको सब समझ में आए। So this is how you convert the number, that is 123.41. Here 23 point radix is decimal point and we are converting to a binary number. So we have to do successive division on integer part and successive multiplication on fractional part to give you the right answer. Okay, and this is the final answer. Any question, any doubt you have? Any question, any doubt?
Sir, in successive multiplication, where do we have to stop?
हाँ, it depends upon आपको कितने पोजीशन। अब मुझे I am interested in only 3 positions.
Okay.
ओके हाँ, आपको अगर 4 पोजीशंस में इंटरेस्टेड है तो आपका वो जो नेक्स्ट वाला था
0.28. 0.28.
0.28, ये 0.28 को फिर से आप मल्टीप्लाई करो, जो भी आपको आंसर आएगा ओके तो आप वो लिख सकते हो. सो इट इज
Okay, sir.
टोटली डिपेंड अप. हाँ, तो आप मैक्सिमम 3 प्लेसेस पे जाओ, मैक्सिमम मत जाओ. Sometimes it may be given in the question also that you have to take 4 positions, then you can continue this. Otherwise it is understood कि you can go with only 3 positions. Fine.
Okay, sir.
Okay. So today I think what is the time? It's 11 now. So today we have seen how the conversions are done, because today's lecture was dedicated for conversions only. But before conversion, it was my duty to tell you actually what things we have studied. Okay, so you have understood till now the different number system, their representation, the position value, the place value, okay, the radix. Then you have understood the significance of the symbols. How do you recognize the number system? Okay, how do you represent the number system? And today actually we have seen the conversion. We have seen the conversion, और conversion में हमने पहला वाला देखा था binary to, it was binary हाँ, सबसे पहले हमने देखा था, ये याद में रखना, ये सब इंपॉर्टेंट है क्या, पहले बाइनरी, बाद में डेसिमल, बाद में ऑक्टेल, बाद में हेक्सा. तो हमने देखा आज बाइनरी टू डेसिमल और डेसिमल टू बाइनरी, ये हमने आज देखा. ओके, तो हम वो सीक्वेंस में जाएंगे. फिर नेक्स्ट लेक्चर में जब मैं आई विल बी टॉकिंग अबाउट इन द नेक्स्ट लेक्चर what I will do from I will see whether it is I should go in the decimal to octal. Otherwise ये तो हो गया, then binary to octal में भी अगर जाना है तो that thing also we can see, that is also simple. तो हम वो भी देखेंगे. Okay, binary to octal. And then from I am talking about the agenda for next lecture. लेकिन ये आपको याद रखना है, ये आपके आंखों के सामने होना चाहिए, BDOH. और ये जो मैं बना रहा हूँ ये भी आपको समझना चाहिए, ये भी आपके सामने रहना चाहिए ताकि आपको समझ में आए. So B2 D2B. See, this is all my personal experience with the students. Okay, so this is what I thought that this view should be clear. So B to D, D to B, then B to O, then O to B, then comes B to H, and then H to B. Okay, और बाद में फिर हम आगे की स्टेप देखेंगे. तो पहले हमको ये सब चीजें करना है. ओके, सो 1 2 3 4 5 and 6. ये 6 में से हमने आज 2 लिए. कौन से? ये और ये. अगले लेक्चर में हम ये और ये दोनों ले लेंगे. ओके, सो बिफोर आई वाइंड अप, डू यू हैव एनी क्वेश्चंस, एनी क्वेरी, प्लीज आस्क. Yes, any question? मनप्रीत, न्यू सीआर.
Yes, sir.
समझ में आ रहा है?
Yes, sir.
ठीक है, बाकी बच्चों का भी फीडबैक ले लेना, मुझे बताना.
Yes, sir.
एंड फ्रॉम बॉयज साइड हु इज द सीआर?
Sir Siddesh Shetty.
हाँ, सिद्धेश शेट्टी. ओके सिद्धेश, हैव यू अंडरस्टूड? सिद्धेश इज देयर?
Yes sir.
हाँ, समझ में आ रहा है ना?
हाँ sir.
ओके, आई थिंक लेट मी सी कि अटेंडेंस हुआ है कि नहीं हुआ. नितिन सर इज देयर? $56 students are present na? Wait, Nitin sir is there?
Sir Nitin sir थे अभी leave क्या
Sir
होंगे?
just left.
अच्छा, he left ना? अच्छा, that means he must have taken. Okay, okay, then we will see the next lecture. एक मिनट रुको before you leave. I think I have lecture on Monday ना? No, I do not have yes, I do not have lecture on Monday. So what I will be doing, I will be taking Chintan sir's lecture. Chintan sir का lecture मैं Monday को लेने वाला हूँ. Okay, and timing will be I think at 11 o'clock. Okay, so whatever changes are there, I will convey through the CR. Okay, but Monday I am having my lecture. You can join on the same link, and I will convey at what time I will be taking lecture to the CR. Okay. So everyone can leave now. Take care. Bye bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Bye bye.
Thank you, sir.
Thank you, sir.
Bye bye. Take care.